Hello everyone, my name is Chiyoung. I'm from Couchbase. Today I'm going to briefly introduce the ForestDB which we developed as the new storage engine in the Couchbase NoSQL database systems. Oops, sorry. What's going on? Yeah. All right. So first of all, let me explain the motivation for this project. B+3 has been used as one of the main index structures in the database domains for more than 4 decades. But B+3 has been known as, it is known that B+3 is not efficient to index the large number of long length keys because entire key string should be indexed in the non-leaf node in the B+3. So consequently, the depth of the tree grows because the fan-out degree of the B tree will increase too as we insert more and more data. So the I/O cost in traversing the entire B+3 will increase as the data size is getting bigger and bigger. So to address those limitations in the B+3, several variants of the B+3 have been proposed, such as LevelDB, RocksDB, and RiotTiger, which are based on the log structure merge tree, and also TokuDB, which is based on the fractal tree from Tokutech companies. So at Couchbase, we also observed the similar limitations from B+3 because Couchbase used the typical B+3-based storage engine. So to address those limitations, we developed ForestDB, whose index structure is built from hierarchical B+3-based trie, we call HB trie. Using this new index scheme, we are able to achieve the much better read and write performance compared with the traditional B+3-based storage engine. So this diagram shows the high-level overview of the new index scheme, which is HB trie. HB trie is the variant of the trie index structure where each node in the trie is constructed using separate B+3. For this, we split each key into the list of fixed size chunks and then construct the first level B+3 using the first chunk, and then second level B+3 using the second chunk, and so forth. So in this HB trie index scheme, each leaf node in the B+3 can point to either next level of B+3 or actual key value pairs. So the tree traversal will start from the first level of B+3, and then if necessary, it'll go to the next level of B+3. Or if a given document is found, then we'll return that corresponding key value pair from index. So one of the main benefit of this new index scheme is to maintain very compacted index structure by identifying the minimum set of the chunks that can distinguish all the keys in the application key space. So in other words, we don't need to construct the separate B+3 for each chunk level. So as an example, this diagram, for example, let's assume that the application keys are randomly generated, such as UID or hash value. Then in this case, most of the keys can be indexed by using first chunk, which means we only need to construct the first level of B+3 using the first chunk. Now, we don't need to store entire key string in the index. As another example, if many keys share some common prefixes, then we don't need to construct the separate B+3, layered B+3 for those prefixes. But instead, we just need to identify the first chunk that can distinguish those keys which share common prefixes, and then construct the corresponding B+3 for that chunk. So basically the idea is that we want to, the high-level idea is that we want to maintain the compacted index structures by identifying the minimum set of the chunks that can distinguish all the keys in the application key space. I think that's, yeah, thank you.